All right, so today, your job for your warm-up. We've never done one of these, so it's totally new. You're going to have to wait. Okay, on your warm-up, this is a question from the test. It says, write an algorithm that you used when adding or subtracting a rational numbers. Explain what the algorithm means in words. Remember to use the math writing rubric. So on this little part over here, actually I'll put it up there, the mathematical writing rubric is pretty simple. The first thing that you'd want to do, does anyone know? Hudson?
Right. Think of numbers.
Close, not bad. It is called restate the question. That's the first thing you need to do. Second thing, Lucas, answer the question. Then provide an example. And basically the last thing you're going to do is explain your example. Now there's a few other things that you do when you're done. One would be check your sentences. Right, for grammar, punctuation, and all that. The second thing, check vocabulary. And it should be math vocab. So we have 4 parts that you need to do. You got to restate the question. You got to answer the question. Provide an example, and explain your example. So let's go back to here, because I've given you 2 examples of 2 open response questions. So we have write an algorithm that you use when adding or subtracting rational numbers. Well, if I go here, it says, so a smaller rational number. Did they restate the question? No. So that you could restate the question for this one. What about this response? An absolute value negative that's close to 0 minus a greater absolute value negative equals a positive. Did they restate the question?
Yes.
No. The question is, write an algorithm. So they didn't restate and they didn't restate. Talk your tables. Did this one here, did they answer the question? Go, talk your tables.
No.
Explain why. If you say yes, explain why. If you say no, explain why. How do you know?
Well, the answer to the question would be showing an algorithm.
So Shay, I heard Elle say, it says write an algorithm that you use when adding and subtracting. Do you see an algorithm? No. Did they try to explain an algorithm?
Yeah.
They did. They didn't do a great job, but they tried. That's okay. So they're trying to explain one. They didn't show us one. What about this? Did they provide an example in this one?
No. Well, kind of. Yes, smaller rational.
Kind of. That's more about they tried to answer the question that way. But they didn't explain what this small rational number is. Do you see a small rational number in here? No. I don't know if it's 1 or negative 20. They're both small. Right? Or I should say 1.1, because 1.1 would be a rational number, or negative 20.2? I don't know, because they didn't give me an example. And if they didn't give an example, did they explain an example? Nope. What about this one? Talk to your table about, did they answer the question? Go. So Gavin, did they answer the question? Yeah, they did. They definitely did, right? Here's an algorithm. Is the algorithm correct? Yeah. If I have an absolute value negative that's small, and I subtract an absolute value negative big, subtracting a negative is like?
Adding a positive.
So it's like adding a positive. So yeah, I'm going to end up with a small positive. So this makes sense. And they explained it. So yeah, they answered the question. They didn't restate it. They answered it. Did they provide an example? No. No. That's an answer. An example would be negative 5 minus negative 10 equals positive 5. That's an example. And then I can explain the example. That's going to give you full 4 points. So here's your job. You have about 5 minutes. You have 5 minutes to work together as a team. You can either choose this one, this is the more challenging one, or this one, which is a little bit easier. But I want you to make that one better or that one better using this. Go.
You should say that an algorithm is okay.
Yeah. I mean, you can.
Negative.
Right after you
So that one, it had an example and explained it, but it
Work
didn't
together, guys.
answer the question.
Work together. I want you guys all working together.
So I provided the example and explained it.
right after that you can use with adding and subtraction. So you can
Yeah, restate that question first. That's the first thing you should do.
say
So how do you restate this?
an algorithm that I can use with adding and subtraction rational numbers.
Is. Bam. Write it down. Okay.
I don't have my
It's in the yellow.
An algorithm I use when adding or subtracting a rational number is.
Yeah, I love it. Jillian was using the rubric.
So after we explained an example and answered it, we need to provide, explain our example. So we should say, I wrote and subtract and because that explains why a sum of subtract rational.
You got 2 minutes.
Algorithm is rational.
All right, so someone like to share a response. Let's pick the easier one. This one down here. Hudson, he's being a brave soul. I like it. Taking a risk. We all know that helps. Become a mathematician. Hudson, go for it.
An algorithm I use when adding or subtracting a rational number is -10 subtract -11 equals 1, which is also equal to a smaller negative subtract a bigger negative equals a smaller positive.
So let's see. Did he restate the question? Yeah, he did. Did he answer the question? Provide an example. Boom. Did he explain it? Okay, the only two down here, you can tell he had sentences. I would say vocabulary. He could have maybe used absolute value. I mean, there was a couple things, but minor. But that's a great response. That's how to take this and make it better. I'm going to add this poster. It will go over there and replace that one, because really it's this simple. You just got to do these things over and over and over and over and over. This is how you respond. What I'd like you guys to do, put away your warm-ups. Have on your desk your reflections that are due today. And I'm just going to talk to you real quick here. So, what? Yes, I do, Chad, right over there. All right. So, you know on Tuesdays we zap. Okay. We got the list. You guys, I don't know what's going on with this grade, but the list is huge. So, the team and I, we're talking. Now, I love the idea that if you're not getting zapped, you're going outside. And remember, when you get zapped the entire time. So, we might increase zap to 3 days a week. Because this is not okay. You're just not doing your work. Or you're doing work and it's below what's accepted. You guys are a smart group. You're chatty, yes, and it's affecting your grades now. And I can say that because I put in grades today. Some of us did really well. But some of us did not. We need to do a better job at our mathematical mindsets. Here are the mindsets. Checking your answers. I don't care where you check them. You can check them over there. You can check them over there now. I got 2 boards. I could even be like, Elle, what'd you get on number 5? I can check with a partner. And we can have a conversation. I can check with Ava. Be like, hey, what, really? I got this. Ava, what'd you get? We can have a conversation. But if you're not going to check your work, remember, this is not 6th grade where I go down each problem one. I don't do that. I don't think that's good for your time. But I do believe I need to do a better job at helping you guys do this. You must check to see if you did it right. Just because you did it doesn't mean you did it right. The next thing, and I'm getting better at this. When you get stuck, Jillian, think about what you know. Think about, okay, what's the problem asking me? What kind of answer and then what do I know about this problem? And write that stuff down. Even if it's not what the answer is supposed to be, write it down. You'll get somewhere. And then this one. When you're stuck, ask questions to me, ask questions to your peers. But these mathematical mindsets in this class have to get better. And it's showing on the test. Our average was a 74, not bad. That's 3 points lower than last year. Last year's average was a 77. So, I know that you guys can perform mathematically better. But if you're not willing to check your answers, you're going to make lots of mistakes and think you're doing it right. I mean, that's one of the reasons why I like Khan Academy and stuff, because it tells you when you make mistakes. But you guys need to realize in this class, we don't do Khan. I do it in intervention. You need to be responsible for checking your work. Because I can't check every single kid's work. It's impossible, right? There's 25 of you guys, or 24 of you. Yeah?
Is it the entire grade or just this class?
No, I meant the grade. The whole grade had an average of 74. Some people did really well. I mean, I had 2 kids get a 37 out of 38. It's awesome. I had a whole bunch of kids. I think 12 kids get 32s. Awesome. Because you know my tests are hard. They just are. But this is what I'm worried about, and then I'm going to get going. This is what I'm worried about, Jillian, is that let's say you got a D, and you don't do the relearning, right? You don't come up, you don't grab the paper, you're not like, yeah, I'm going to take this test again. Which a D, I'm not going to make you. Let's say you don't do that. Is your learning solid, or is it kind of fragmented? Fragmented. Okay. So it's fragmented here. What do you think is going to happen on October 3rd? Do you think it's going to get better by then?
It could.
It could, and it might not. So tell me, if it's not fragmented here, are your chances better here?
Yes.
Yeah. So that's why I encourage you. If you got a C, that's good work. It's not great work. It's good work. Because like I said, I think my tests are hard. I'm trying to challenge you to step up your game, and a lot of you have stepped up with these mathematical mindsets. But I can tell you, if you did not do well here, you're not going to do well here. And that's why I care so much about you guys. I'm not going to let you go through failing my class. That's just not how I teach. And that's just not me. I'll do what it takes for you to learn the material. But you guys can help yourself by being better students and more mathematical mindsets. And you can help each other be accountable. Because I have noticed the ones that are chatty, that I have to move sometimes, they did not do well. Because you're not being focused. And you have to understand, that comes back on you now. Because one, you're going to have to do this form. You can do this at home, which would be awesome. But if you don't do it at home, take us when you do it.
Today at school.
Today at school. Not today, but tomorrow. So, and then you have to take the test, which is like 2. It's like 2 of your free times get taken. So, if you're like, I already know my score, I want to take a retest, or I don't know my score, but I'm pretty sure I didn't do well, come and grab one of these right now so you can do it at home. Okay, I'm going to release the scores so you're going to be able to see them. Okay, I already put them in Infinite Campus, but I haven't released them yet. Yeah?
Are we going to check our scores in the same time if we have?
It's ZAP. We only do that on Mondays.
Oh, yeah.
Yes, Marcus.
Do I have to do the test?
You'll have to do the test, but it'll be tomorrow. Yeah. Chad.
I don't really know Zap in any class, but can I come into your class to finish up some homework on this?
Yeah, man. Yeah, of course.
And check in.
Yeah. That'd be awesome. All right. Jillian, last question.
If we have 4 tardies, we have to stay for Zap and recess?
Yeah, I know. You got to get to class, girl. You're like, no. All right. Okay. Oh, my homework helpers didn't get the homework up. But that's okay. This is what we're going to do. So tomorrow, Shay, when you walk in, Elle, when you walk in, go right to a board. Don't worry about it today. Did you do the warm-up? Yeah. So you're good. Remember, you don't have to do the warm-up this week. Shay, did you do the warm-up? Awesome. You're good. Remember, you get to walk in and go put your homework up. But because we didn't, please get your reflections out. I'm going to collect those.
With our other sheets.
No, just your reflections. Please! Hey, make sure your name, check right now, is on your paper. Please bring them up. Pass them in. No, reflections are here, bud.
Thank you.
Welcome back.
Found it.
Okay, you got to come during your time.
Okay.
Is that bothering you, huh?
Very much.
I like squigglies. Squigglies are awesome. No? Thanks, Clover.
I'm thinking I did a good job on the front, but on the back,
Okay. Do I turn in?
Name. Otherwise, it's going to go in as a missing.
No, you gave it to me. Just give me the present back.
All right. Please get 3.1 in front of you. So, we got this up here, Eva? Remember, if I don't get your reflection now, the only time you're going to be able to give it to me is at lunch or in the morning or right after school. And then I'm going to make you wait. I'm going to grade it then.
This one doesn't go in there, right?
Okay, no, not the review. Thank you. All right. Algorithms. We're still on the algorithm kick because they are awesome. So on 3.1, we're going to be looking at multiplication patterns. So an algorithm is a series of steps, Gavin, that help you understand a mathematical situation. If you guys remember, if you look in the back of the room, we have algorithm subtractions, right? Algorithms for subtraction and algorithms for addition. Between the two of them, there's over 12 algorithms. Like, oh man, I got to remember, like, if this is absolute value minus This absolute value is going to give me this. I have to remember if it's a negative, then I have to add. I mean, it's a lot. Multiplication and division. Easy. There is only 4. And they're easy to remember. So when I write, what do you guys do? You write. We got a positive times a positive. Well, that equals a positive. And that's what this means, Rayanne. If I have a 2 and I multiply it by 5, I get a positive 10. We already knew that, right? Already knew that. Positive times positive, positive. Now, this one is new. A positive times a negative is a negative. So if I go 2 times negative 5, you guys, the multiplication is the same. The division, always the same. I just say, well, that's a positive, that's a negative. So that equals a negative 10. Because I know what 2 times 5 is. That's 10. So now it's just negative 10. Hold on. A negative times a positive is a negative. So negative 2 times positive 5. Well, again, I know 2 times 5. That's 10. It's just negative 10 now. Talk your tables about this one. Go. So a negative times a negative equals a positive. That's the one that kind of confuses kids. So basically, guys, negative 2 times negative 5 equals positive 10. Here's the thing that you need to remember, Eva. If the signs are the same, it will be positive. If the signs are different, it will be negative. Signs are the same, positive. Signs are different, negative. Signs are different, negative. Signs are the same, positive. So when the signs are the same, it's positive. When the signs are different, it's negative. Now, this is what I love about this, because you see with the adding algorithms and the subtracting algorithms, you got to remember those sayings, right? Subtracting negatives like adding a positive, right? You have to remember those. So the relationship between dividing integers and multiplying integers is the same. So when I write, you write. Multiplication and division have the same algorithms for rational numbers. That includes integers. You could, yep. You could put like integers underneath, right? So what does that mean? Well, I'm going to switch to my favorite color, blue. So it means this. 10 divided by 2 still equals positive 5. Because that's a positive divided by a positive. Right? Positive divided by positive, still positive. Nothing's changed. Negative 10 positive 10 divided by negative 2, that equals negative 5. The division is the same. I love it because it's like, oh, good, don't confuse me. I don't need to worry about, right, whether it's negative or positive, and it's the same. So we go to the next one. Negative 10 divided by positive 2 equals negative 5. Because again, these signs are different. It's a negative divided by a positive, so I get a negative answer. And then, of course, the last one, negative 10 divided by negative 2 is positive 5 because the signs are the same. This is like a breath of fresh air because 4 algorithms much easier than 12, right? So, and you don't have to worry about absolute value. It's normal. The only thing you need to remember is, oh, that's negative, that's positive. My answer is going to be negative. Oh, that's negative, my answer is going to be positive. It's really easy. No more absolute value stuff, worrying about which one's further from 0, none of that. So, is there a pattern? Oh yeah, I forgot to do this. Is there a pattern for determining an answer is negative? You need to fix that. Or positive. I don't know why I forgot to correct that. I put odd or even. I must have been tired this morning. So, when multiplying integers, yeah, there is a pattern. If they're the same, positive. If they're different, they're negative. So, let's look at this one. So if I do this, negative 3 times negative 2 times 4. Talk your tables. What does that equal? Go.
Wait, what?
Negative 3 times negative 4 times negative 2 times 4. You got it, Chad? What'd you get? Think about it. Hold on. Okay. So, Jillian, what is negative 3 times negative 2?
Since it's the same, it's positive.
That's a positive 6.
So, yeah.
And then what is 6 times 4? 24.
25.
So, these were the same, so it became positive, and then those are the same, so it stays positive. But what about if I do this?
So commutative, whatever that's called, isn't valid.
Oh, it is. It is. It is. Oh, no. Ready? Look. Negative 3 times 4 is negative 12, right? And then negative 12 times negative 2, negative times a negative? Positive. It still works. Do this one. Go.
Negative 24. Once you get the answer, they're all the same. So it would be 2, which is positive 6, and negative 4 is going to be negative. They're all negative.
So I go again. Negative 3 times negative 2 is 6. And then 6 times a negative is going to give me a negative 24. You know, Clover asked a great question. She said, well, is it commutative? Yeah, it still works commutative. I can multiply these numbers however I want, and I'm going to get the same answer. So, this is what I love about this, Naomi. This is so much easier than adding and subtracting negatives. So much easier. Okay? You just got to remember those 4 algorithms, Shay. Right, Olivia? And you're golden. Okay, today, we're going to be using these algorithms, and I'm just going to say that I feel like the work is not easy. But I feel like once you get through A, it gets way easier. But A kind of starts off a little rough. I just want you to do this. First of all, what's it asking you? And what do you know? Write down what you know, and I feel like you're going to get somewhere. So it's on 3.1, page 56. It is A1A, A1B, A1C, and A1D. And Oliver, mathematical mindsets, check your work. I could ask Al what her answer is. I could go over there, check my answers. I can go over there, check my answers. I can talk to someone beside me what my answer is. But do not just do work without checking. And then if you're wrong, ask me a question. Okay, I'm going to combine. I'll probably ask you, hey, what do you know about that problem? All right.
So we're not solving it, we're just writing down what we know.
Write down what you do know if you can't figure it out.
We're doing this
can figure out. Then
Or are we doing it independently?
Uh-huh.
Are we doing it independently?
I want you to start independently, and then we'll work into the group stuff. Nope. First keep going on this. Anybody use the bathroom?
How would she start a thing going 5 days and then after 6 seconds you get to? Because
Marcus, focus.
You want them to reshape this or What do you have, man?
Right there.
I know.
3.1, right? Oh, yeah. These are possible answers. So they're possible answers. So your answer should be one of those. Does that make sense?
it's 5 times 2.
You got it now?
All you got is this.
every second.
6 seconds later. It would be 7 seconds. 4 seconds later. Add the
No. No, because there's
Hey, that's not bad. That would be negative. Is that a negative 6? Okay, all right. Good, that's it. Yeah, 6 times. Boom, perfect. Yeah, so B, because you have to write a number sentence, right? So B would be what? Because she's running to the left. So here's the start, and she's going that way. Going the wrong way. So what kind of value would that be? A negative value, right? Because instead of like when they say on your marks at go, she's like going wrong way. What do you got for A? Yeah, but what about A? Because you got to get A done. What do you know about A? So how far is she in 1 second? Two seconds. Okay, so you know a lot. But you gotta do B2. A through. God, shit. Keep going. Come on. Good. I like it. Nice work, Olivia. Thank you.
Like I'm reading it, but like don't read it. Wait, now that I see what you mean.
Chad. So on C though, on C, where was she 6 seconds earlier means it's a negative 6 seconds. So she was at negative 24. She wasn't even at 0 yet. And then this one, yeah, but it's negative 5 times negative 7 positive. Did I do that wrong before? You're right. Okay. Good. Yeah, looks good. Do this right.
I'm missing some homework. I don't know.
I'm glad you ran away from that person.
Really not necessary. You learn.
That was very easy.
You want to do this, okay? You, so super close. Olivia, I gave you. Try to do it tonight, see if sometime tomorrow.
I know, I don't like
Tomorrow.
Why is that pink?
Yeah.
So would you add the
Well, you tell me. So what do you know?
Well, I know that,
So so in 1 second she goes 5 meters. So what about 2?
well, that's 2 minutes.
So the question is, how far is it in 6?
Wait, so that's
Write the number sentence. Well, he's writing right.
They're on like
Questions, questions.
Keep writing that.
like when you are thinking of something, like also you could tell
Work?
6, 7,
You do, Jill?
no, yes, I do.
I'll tell you writing a story about your
Right, because it's like 6 seconds early, right? Or is it running left? Yeah, running backwards again. Yes. Negative, yeah, because it's before she gets there. Yes.
It's like, I'm not sure what happened. She ran for 8 seconds. So these 6
I was thinking I already had that on A1.
maybe it's sometimes 8.
What's up?
No, I'm
How
on
well is that? How you doing on this? You understand it? Remember those algorithms, okay? Remember the algorithms. What are you doing?
I keep writing.
You need any help with your algorithms or anything?
No, I just keep writing.
I got it up on my computer.
Oh, okay.
Awesome.
Can you not get it? I wouldn't let you in.
One B? Ooh, yeah, this is a good one. Just think about it. I want you to sit and think. Talk to Jillian. Work together. Hey guys, B, I really like B.
I love it.
Because you got to think about it. It's a really good question. What'd you get for it?
I got that.
So it's going to be negative 6 times 8 negative 6 equals negative 40.
And you get the same answer of what? That's where you just got to go a little bit further. What'd you get? Negative 40.
I'm still stuck on C. I don't understand.
So it's 6 seconds.
It's a perfect.
Oh. Oh, this one. Oh, yeah, you do. So what's the question asking you to answer?
What's the difference? Wait. Oh, what are the patterns?
Okay.
And the
So now look at it.
That's 5.
Okay.
So
You got it, right? I knew you would get it. Sometimes it's so easy, it's confusing. So easy is confusing. All right, guys. We have to put away our work. No, you were supposed to do B, A1B. That's A1B, A1C, and A1. That means through. Oh.
yeah, the first time I saw them, I'm like, do you want me to do A1 and AD? But I'm like, wait, that means through. A1 was very easy through AD. But B, it caught me.
Okay, so let's come back together. Target. So our learning target, Winton. Our learning target had everything to do with understanding those 4 basic algorithms.
Thank you.
And the saying is this: when the signs are the same, it's positive. When the signs are different, it is negative. So, homework. You have 9A through F. Written. That does not mean 9A and 9F. It means 9A, 9B, 9C. They are not difficult. You just have to remember the algorithms. And then 10, A through D. And again, you just have to remember the algorithms. Test. 10A, 10B, 10C, 10D.
And then exit ticket.
The exit ticket, well, because we're looking at algorithms for multiplying, that's what today was all about. So what am I asking you to do? Write an algorithm for multiplying, and then I kind of threw a little bit of a curveball over here, because that is division. But it's really not a curveball, because I'm not going to. I would write down. No, you don't have to. You don't have to calculate. But write this down. Yes, that's multiplication.
Just put like negative times negative.
So Rihanna, I have a negative number. I'm multiplying by another negative number. So what's my answer going to be? I asked Rihanna, not you, Buster. Rihanna. So, why is it a negative times a negative equals positive? Because the signs are the same. But, here's the curveball, Lucas. I put a division sign. So, Lucas, this is a negative divided by a positive. Lucas, what does it equal? Shh.
Oh.
It equals no.
It equals a negative.
And this is why it equals a negative. The signs are different. When the signs are different, it's negative. When the signs are the same, it's positive. Not to the bell. I would encourage you guys to do this. Clover, Grindle.
Did anyone do the complicated version of the warm-up?
Yes. Yeah. There were three groups in the time before that chose the top one.
Not in school,
Not in this class. Yeah. And then in first hour, everyone chose the bottom one. Or second hour. Like I said, guys, a 27 average. Not bad on your test. But I do believe that you guys are underperforming at the moment. And it's not because of your ability. It's because of your mindset. You're not capturing enough school while you're in my class. So we're going to work on that. Because the math's going to get harder. And I want you to be successful. Today, more people check work. Today, more people are writing down what they know. Fantastic. Adios, amigos.
Wait, quarantine time first?
Yeah, and then we'll zap you.
On our unit test after that, can I clean out our binders?
Ah, you're smart. I like it. What's up there, bud?